Welcome to Observable Lightning Talks. That's a new format for those who is listening to and following the YouTube channel. Is it observable? Usually, we provide content on how to observe a given technology, and here it's a different format. It's a live YouTube live stream, or LinkedIn, or Twitter, Facebook. We are in fact streaming out in different platforms. So today it's going to be a live event with lots of great speakers, and that will share lots of interesting concepts. So you will be take a lot of output out of that. Of course, if you enjoy today's content, as usual, don't forget to press on the like button, to subscribe to the channel, because this format, the Observable Lightning Talks, we will have it once per quarter to start, and maybe we will have it more often, but at least for a quarter, it's enough to start. So what is Observable Lightning Talks? Well, very easy. So Observable Lightning Talks is about providing content that we are covering in the YouTube channel. So usually the YouTube channel covers three main topics: SRE, observability in general, so any open observability frameworks, and also focus on open telemetry. So today we will have three lightning talks covering those three topics. So we will have a dedicated presentations on the SRE topic, one specific to open telemetry and open observability in general and open source initiatives. And last, we will have an open observability presentations. So at the end, of course, you're able to interact with us. We will have a dedicated panel discussion at the end, where I'm going to ask questions, because I'm going to probably going to have lots of things to ask to those various speakers. But also, if you want to drop your questions related to one of the presentation, use the chat options of LinkedIn if you're connected through LinkedIn, or Twitter, or Facebook, or again YouTube. You can drop your comment or questions, and we will try to answer them during the panel discussions. All right, so what are the agenda? So let's have a look at this. So we will start this event with Steve McGhee, who will talk about non-standard SLO beyond availability. So very focused on SRE topic, like I mentioned before. Second, we will have Alolita Sharma, who will talk about open source observability and open telemetry, a win-win for users. We'll see all those open observability framework and standards is a great advantage for us in our projects. And last, we will have Michael Hausenblas that will talk about observability fundamentals, the open standards. So lots of great speakers today. And also, we will, don't listen to what they have to share with us today, and don't forget to drop your questions. So without waiting anymore, I would like to start with Steve. So let's introduce Steve.
Ça va, Henrik? How's it going? I'm Steve McGhee. Hi, everyone. I'm going to talk today a little bit about SLOs. If you've heard about SLOs before, I'm hoping this will be like a slightly different take on the SLO talk you've already seen in the past. So just to get started, this is me in black and white. So I've been working at Google for a while. I was an SRE in a bunch of different services and products that you can see at the bottom. At one point, I left Google and I joined a company here in California to help them move onto the cloud and adopt cloud native technologies, adopt SRE, become more reliable. And I learned a ton. I moved back to Google to basically help more companies go through that same process. And it was, it's been a blast doing that ever since. One thing that comes up a lot is SLOs. So this is like a distillation of SLOs into one slide. Like if you've never heard of SLOs before, this is going to be like too much in one place. But like if you've already heard it, this is a nice debrief, or maybe it's a rebrief. I'm not sure. There is a link at the very bottom here from the Google Architecture Center about defining SLOs that goes into it in a lot more detail. But essentially, SLOs are really a ratio of good to total. So it's like how good is our system at any given time, and it tends to be measured over a time duration. This can be something like 2 weeks or a quarter or maybe a month, something like that. It's generally not like an hour or something short like that. You want it to be kind of business timeline centric. Um, the idea here is like if there is like too much of the non-good stuff, we want to tell someone to step in and change something, right? Basically, you paid somebody. Um, this is a very high level abstract concept. Um, and the important points to think about here is on this graph here, where you can imagine if we dip below the red dashed line, that's when we're in like the bad territory. So the line itself that's moving around, you can think of that as a metric or a KPI of some kind. We call this the SLI, the service level indicator. And the SLO is like the goal. So don't go below this line, right? Or if you do, start accumulating errors. And so the area under the curve is what we call the error budget that has been consumed. And so you can imagine if you have the expectation of 3 nines of availability, you can have 0.1% of your requests are going to be allowed to be errors. And so you measure those by measuring the area under that curve. Okay, that's it. That's all of SLOs in one slide. So most of the time when we show this, we provide the example of availability and latency. So is it up and is it fast or fast enough? Is it up enough? Is it fast enough? Sometimes we even combine them when we say like, is it available and fast enough? So like only count the results that, got back to the user within some cutoff amount of time and consider that to be good. That's a little bit fancier, and some companies do that. But there's got to be more to it than that, right? There's another link at the bottom here. So this is like the second link in this 2-part series of documents. And most of this talk is coming from that second link, adopting SLOs. Okay, so what else is there? Like the availability and the latency examples tend to be around what we call request-driven services. So I request a resource, or I do a get of some kind. Maybe I even do a post or a delete or something like that. And I expect some response back, either a rendered web page or just like an API response like, okay, good, right? Or maybe I get like the contents of some bucket or something like that. But there are other types of executions and workloads that we care about on the web, and even internal services, right? So some examples would be like data processing. So having pipelines that are running all the time on huge amounts of data, and they're generating something, some new view on the data or a model of some kind. We also have lots of scheduled execution systems where something needs to happen 1 hour from now or at 10 a.m. on the dot, right? Things like that. So these things it doesn't really make sense to talk about availability and latency quite the same way. And so we have to use some other word, some other measurement that we want to make. You can imagine also, like in this new modern age of ML models, like dealing with models, whether we're generating them and training them, or we're utilizing the existing training ones, it gets really complicated. So at the end of the day, in order to use SLOs, you need to be able to define 2 words. What is good and what is the total? And generally, if you can get the good, you can pretty much get the total. But let's just start with getting good. So we're going to go into each of these kind of like English words and describe what they mean in an SLO context. So if we're talking about freshness, generally in the data processing, like think of like a pipeline, we're talking about the proportion of valid data that was updated more recently than some threshold. And so an example here might be if you're building a video game, you might be generating map tiles in that game, right? So you want to, or maybe even in real life, if you're generating map tiles for something like Google Maps, right? So if you have this huge pipeline system and you're putting a bunch of data in one side and then out the other side, the thing that you pop out the other side has some timestamp associated with it of when it was generated. Then you can measure also when it was then served to the user. And we can find the difference. And we can say, this map tile was 1 hour old when it was shown to the user. Or in a video game, maybe this map tile was 1 second old and it has like updated, elements of where the enemy positions are or something like that. And what we can do though is we can determine that goodness is measured by whatever that delta is, between when it was built and when it was served, compared to some threshold. So we're going to set what is like the acceptable level of freshness, and we're going to ask what percent of the time is our data fresh enough. So by phrasing it this way, you have a really clear, human understandable way of being able to determine if the whole system is working well or not. Oh, wrong button. There we go. Okay, the next one is coverage. So what about the proportion of valid data that was processed successfully? This kind of makes a little sense, right? And so the idea is, if you have a lot of inputs going into a lot of different pipelines and they have a lot of different outputs and things like that, often what we want to do is just make sure that we understand the state of the whole system. Even though the system itself is really, really complex, so like we can't always expect to measure every input and every output and every intermediate state and be able to determine, like, get a big picture of what's going on with the system. So what we do is we talk about the coverage of the entire system at once, which is, again, it's really just kind of it's in this case, we have the number of valid records and the number of them that have been processed, and determining what like fraction of them have not been processed yet or will not get processed perhaps. And again, we're measuring this over time. So we want to be able to say, like, of all of the things we could be doing, we're doing, we're getting through 90% of them. Is that enough? I don't know. Maybe. It's up to you. So you get to set that threshold, and then you're measuring it over time, and you're assessing how well you're doing against this goal that you've set for yourself. The next one is skew. So now we're getting into the cron concept, right? So if we have something that needs to run every morning or every hour or something like that, if you've ever run something in cron, especially a distributed system, you'll find that it doesn't actually run exactly at the time that you need it to, especially if it needs to spin up a lot of resources. Maybe those resources aren't available yet. Often having a little bit of flexibility in your scheduled execution system is really, really helpful, but you still need to keep track of how well it's doing. So in this case, you can have either positive values or negative values, potentially, depending on how your cron system works. And so what we want to do is make sure we measure the time between the scheduled or the intended execution time and when it actually started. So did it start a minute early? Did it start 2 hours late? Right? What was the outcome of the scheduling system? Like, when was it able to get those resources? And then you want to be able to, I have a little like layout format bug. Sorry about that. The min threshold should be, on the line above it. The idea here is you want to have a max threshold and a min threshold. So as long as it is, within 1 hour of the intended window, or within 1 day of the intended window, or maybe you have some pipelines where it needs to be within 5 minutes or 1 minute of the intended scheduled time. Being able to know what percent of these executions actually fit within that window is really, really helpful for understanding like the big picture of what's going on in your system. Another one that's related is then the duration. So once it kicks off, whether it kicks off like on time or near enough to on time, like how long did it run for? And so in this case, we're talking about the difference between when the job should have completed and when it was expected to complete by. So now if we have a job that tends to run for 1 hour every day, over time, if we find that it exceeds that 1 hour, maybe that's a problem. Maybe we need to make some decisions about it. Maybe we need to offer more resources or reset expectations with the customers who are using the output of the system. In this case, we want to make sure that I think I actually messed up the math on this slide. Yeah, the formula is just a repeat. I can fix that later. But the idea here is we want to make sure that you measure the duration, and you can take response to if something is going overboard, if it's taking too long, or if you're another kind of funny one is if it's actually going too short, right? So if you have a job that is supposed to run for 2 or 3 hours and it finishes in 2 minutes, like that's also probably bad. Something happened. And so the idea here is that we're not actually diagnosing exactly what went wrong, but we're able to have a very strong signal that correlates well to, is the system working as expected or not, without it having to be like a very precise number. We're able to give it a range, right? And then we're able to measure this over many runs of the system over a large amount of time, and get like a high level sense of if the system is working well or not. Durability is a weird one. So often people will see the durability SLOs and they'll say, wow, this is amazing. This has literally 11 nines in it. So this is actually really confusing. It's measuring something quite different. What it is it's measuring the predicted distribution of physical failure modes of the entire storage substrate. This involves like different types of replicas, different types of disks, and encoding schemes across the replicas, and all kinds of craziness is going on in order to get this number. The point of this is not to explain how durability is measured, but to point out that it's very, very different from availability, latency, skew, all these other ones. So try not to compare these directly. Like what we see a lot is customers will see those 11 nines on durability and they'll say like, why aren't we getting this out of availability or skew? And it's because it's very, very different. So just kind of put it aside. And if you want to learn more, you should read Alex Hidalgo's book. So pages 203 to 208 describes it in great detail, including a fair amount of math. There's also a link there at the bottom to Google's cloud storage system and where our 11 nines come from there as well. So here's some more terminology. That's it for the funny SLOs, but let's talk a little bit about some more terminology. If you're going to use SLOs, it's really helpful to have consistent words. So we can talk about service and goal and criteria and period and performance, blah, 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 blah. So if you can get all these terms defined within your organization, everyone's using them consistently, you can say things like the SLO will be met for the period of whatever if the performance for that period is greater than the goal of whatever, 95%, right? Being able to make these statements allows the operations SRE team to be able to interact with the business and make sure the expectations are reasonable and that they're actually going to satisfy the business needs. And then everyone can have the same view on how the system is actually running. So it's far less up to like human interpretation. And you can really all just really understand how the system is doing. So one final parting shots. Make sure that you understand that SLOs are a measurement of an entire system. They're not generally component level. They are an abstraction. And so you should treat them as such, right? They are not a perfect distillation of every component in your system. They're meant to be an abstraction of how well your system is doing at a very high level. And that by itself is very useful. You still need to have deep diagnosis. So this is not a replacement for all monitoring. It may be a replacement for alerting. You may be able to turn off the component level alerting systems if you can understand and trust that your SLOs are telling you when customers are unhappy or not. As long as you're able to then follow that up with deep diagnosis. So these abstractions allow you to have one other really big benefit, which is that it gives you consistent understanding of a system through change or under change. So you're able to update the system under the covers, and you don't have to mess with the SLO itself, right? You're able to make the improvements to the system, and you don't have to forget about, did I update the observability along the way? It should stay consistent. The other thing you can do is you can introduce a new system behind the scenes, and you should still be able to use the same measurement. You can make direct comparisons between the old system and the new system, and you can show how much more reliable the new system is. This is all good. So as it's kind of written here, implementations can then change. The side effects of those implementations can come and go, but the SLOs themselves persist. And your understanding of the reliability of a system is consistent over time. And that's it. That's my whole talk. So we have a whole bunch of different types of SLOs. We have a good way of talking about SLOs, and we understand why they're useful to have. So that's it. Thank you very much.
So thanks. That was very interesting. And I have already a couple of questions, but I will leave those questions for our panel discussions because when you talked about it, data processing SLOs and so on, and I was thinking of because I'm currently working on something with the OpenTelemetry collector, and I thought about I could definitely utilize this type of SLOs to keep track on the data coming in and come out if everything is as expected. So thanks so much, Steve. So for those who has any questions that has been during this presentation, you can drop them. We will, of course, answer them afterwards during our panel discussion. So now, after Steve, we have our next speaker. It's going to be Alolita. So let me make the small intro, and I will leave Alolita on stage.
Hi, folks. Good day to everyone. I'm Alolita Sharma, and very thrilled to be joining in for this session of the Observable Lightning Talks. And thanks, Hendrik, for putting this together, because I think this is very useful. Again, we all have about 15 minutes to kind of cover some of the topics that we're interested in. So what I wanted to kind of talk about today is, some of the work that I have been doing on OpenTelemetry, and also really focus on why open source observability and OpenTelemetry are a great combination. What, again, leveraging OpenTelemetry as a bellwether for the larger work that is ongoing in the open source observability projects, both within the CNCF and beyond. So a little bit about myself before I get started. Again, I have been working on the Open Telemetry project for a few years now, about almost about three to 3.5 years, and I'm also a member of the governance committee of the project, so have been super excited about the growth of the project, as well as the diversity of contribution, and a lot of the new features that have rolled out, not only on the collector but on the instrumentation via the 11 language APIs and SDKs that the project has. So I want to kind of go over some of those areas today in this conversation and discussion, and also hopefully get some good answers for some of your questions. That said, I also am a co-chair for the Observability Technical Advisory Group in the CNCF, which is also known as the TAG for Observability, and have an opportunity to work closely with the larger community, listening to both end users as well as other community participants from different vendors, to be able to kind of forge together thinking about new areas as well as existing areas which are being worked on in observability continuously, in looking at the multitude of data that is coming in. So again, that's another area, and I would welcome you to again join the tag meetings, which are typically on the first and the third Tuesdays of every month. That said, want to kind of move forward and just focus in on just a very quick introduction to what observability means. Again, it has uh, it's a very popular term nowadays, but it also has deep roots in the industry as well as the entire discipline of computer science, especially in the world of distributed systems. And observability typically, really means that you're looking at the end-to-end systems that you're building and rolling out, and you have an active understanding of the behavior of the system that you are monitoring. Now, behavior is complex, right? Not only is behavior complex, but systems are complex too. And highlighting, and understanding the different states, the dynamic states a system goes through, whether that's active, whether it's listening or responding, or being able to analyze or correlate. They're all different stages in how a system responds when you have a request that it's processing, or an action that it's working on. So understanding what state the system is in and whether that's healthy or unhealthy is part of what observability kind of focuses in on. And also taking into account and understanding the behavioral patterns that systems have when you're building large-scale systems or services. So telemetry data or observability data becomes a huge part in understanding, how a system functions. And metrics, traces, logs, for example, are very commonly used as processes and data to understand that behavior. Now, that said, I think there are, and there has been a lot of discussion in the larger community on actually creating more depth and breadth in the types of data that one would look at in order to better understand systems. And that's something that has been a very interesting discussion, as you've seen with the growth of profiling, as well as events being incorporated into understanding, and making systems more observable. And as you also know, given the kind of capacity of networks and computers that we have in the larger space, when you are looking at hybrid networks and as well as cloud infrastructure, there is a huge amount of scale, diversity, compute power, commodity, infrastructure that you're using from the public cloud, as well as your own applications and services on top, that greatly influence what kind of data you're collecting, what is the complexity, what is the volume of the data that you're collecting, and also what kind of analysis, alerting, and visualization that you're doing. And all those parts of this whole pipeline of not only collecting but also analyzing and visualizing is all part of observability. So with that little introduction, I kind of wanted to, move into more of the areas that, it's like, so, observability exists and it's very important. But I cannot, emphasize enough how important it is, right? Because as you build large scale systems, which are very complex, they have components not only which are, parts of your infrastructure, whether you're running on public cloud infrastructure or, have your own clouds, and as well as services running in that ecosystem, and then also applications and client devices that might be connected into your entire service, right? So every aspect, when you really want to do observability well, you want every aspect to be accessible, right? It's as fundamental as security in one sense. Every layer, every service of your in your whole stack, every application, every component, every feature, as much as you can instrument, the better, and deeper and wider information and data you have in order to be able to better understand the behavior of your systems and be able to actually prevent failures as much as possible. And if there are failures of, to be able to quickly understand what some of the root causes are, which really leads you to prevent, such failures in the future, right? So it really is part of future proofing a complex system in the long run. That said, again, just wanted to call it out again graphically, that what does making a full stack for your application really mean from an observability standpoint? It really means that observability it touches every single area, just like security does. And when we build different features or different libraries for observability, they integrate with every part of the system in order to be able to actually collect data and then be able to process it, analyze it, apply different techniques to have a deeper understanding across different data types and be able to pull that, right? So you have applications, which could be web applications, mobile apps, e-commerce apps, devices doing different kinds of performance metrics, calculating graphs, doing maps, it could be anything. And then at the application layer, typically you end up instrumenting your application to be able to, again, send the necessary telemetry data that you want to collect from the application to better understand, how it's functioning. And tracing is also very integral to application monitoring, where you are looking at, what the transactions are in the applications and how, well are they doing from a system performance perspective. Frameworks, languages, and databases and other parts, infrastructure, includes VMs, storage, containers, and that layer. Then you have more of the foundational layers, which is networking and hardware, where you are very much interested in response time and throughput and latency and bandwidth as well as at the hardware layer at a minimum, CPU, memory, disk. These are examples of, some of the kind of metrics or logs or traces that you collect. But there's also more. There's a lot more. I mean, but fundamentally, it's like if different layers of your system are not instrumented to begin with, then understanding why and where the failure occurred is difficult, right? So moving on, why this foundation? Because observability matters. If the more you understand your system, the deeper insight you have into how a system can perform well and deliver a quality of service that you really want to guarantee to your users. And this kind of goes back to some of the discussions around SLOs and SLAs, which really ensure that a quality of service is being delivered to the end user. So enter OpenTelemetry. Why does OpenTelemetry matter? First of all, for those of you who don't, are not deep in the project itself, OpenTelemetry is a new telemetry system. It's an open source project which collects and processes traces, metrics, logs, events, and profiles in an integrated way. Events and profiles are new. They're just, starting to being worked on the project, and I'll kind of dig into that a bit more. But OpenTelemetry provides a specification which is really foundational and provides a baseline which the entire industry is working on together on the project to define a specification that then is implemented in the SDKs, the APIs, as well as the data protocol and the collector, which are different components of code components that are built on the project itself and are used for a diversity of collection mechanisms, both push as well as pull mechanisms, where you can actually push data or pull data using OpenTelemetry and gathering different types of data to again analyze and visualize. So the OpenTelemetry data protocol, again, is a very well-defined protocol. It's very commonly used. Almost every service, observability service that you use today does talk OpenTelemetry. If they're not supporting it yet, they are working on it. But it's phenomenal to see that diversity of vendors as well as end users coming together, working together on the project to be able to define the data protocol, the specification, as well as the requirements for what is needed as a baseline of telemetry for APIs and SDKs in the 11 languages that are actually being developed. There is a foundational and a complex component called a collector, which acts as a collection agent in OpenTelemetry. And again, this is a composite of several components within it, both not only talking to different types of data sources, but also exporting your collected data to different backends, right? And also introducing and supporting sampling as well as other features for processing that data. So why does OpenTelemetry matter? And this goes back to the crux of the larger discussion that, hey, why are we talking about OpenTelemetry? What is the future of open source observability? And, how are they interconnected? So in my work on the project, as well as, really working as a community with other maintainers, as well as other contributors, it's been phenomenal to see the thousands of engineers, as well as, other subject matter experts in the observability space come together and think about, not only the data, the protocol, but also the implementation of how to make observability more standardized and how to leverage open source, collaboration, as well as open source software development life cycles to be able to really, commoditize the nuts and bolts of observability at scale. And what this means is that it's kind of a bellwether project because, as many of you know, OTel is as the second largest project after Kubernetes in the CNCF space. And that says a lot because it really is an industry effort to be able to commoditize the nuts and bolts of observability at scale. to be able to develop a standardized open source observability framework. And why that matters is that it really gives and empowers the application and service providers, whether that's internal or external, to be able to leverage and standardized framework to interoperate, be able to, take data from different sources, collect data, gather, process, and then analyze at scale the petabytes and petabytes of data that we are all collecting for our services and applications, and being able to pipe that through in a standardized way. That's important because what that does is it guarantees interoperability with one set of APIs, one agent, one preprocessor for all the different types of telemetry data signals, and also provides a vendor neutral way of being able to have a specification that everybody agrees on, because it's not just stovepipe implementations at that point. You actually are instrumenting ones, deploying everywhere. That's a big deal. It saves you on engineering, as engineering is always very precious. And at the same time, also the ability to interoperate gives you observable components, which really can touch all the way from edge devices to core services in your core infrastructure on a public cloud architecture, right? So again, that swath of standardization really brings the ability to look at data at scale in a standardized way, and being able to process and ship. The other aspect, which actually is very important to also understand, and why OpenTelemetry matters in the growth of open source observability, is that it again is a project that provides the foundational infrastructure for the automation of future smart systems. And that's a big statement to make, because at the end of the day, we are moving towards an age of smart systems. And one of the quests of observability has always been to enable intelligent root cause analysis, to be able to enable self-healing, self-learning, and self-evolving systems. And today, there are some systems, as you already see in smart systems, which can kind of self-learn and self-tune and self-heal. But we are still moving towards intelligent systems end to end, which actually, both on the service side as well as the client side, can continue to self-evolve and self-learn, and observability provides that path towards doing that. And open source is observability projects that are some of them within the CNCF umbrella as well as beyond, provide that path towards what is in the future of open source observability. So that said, again, that was something I wanted to kind of emphasize, because that's the world we move towards as we have complex systems, so much data that we are collecting, and also we would like to understand how to make sure our data helps us in intelligent analysis. So just wanted to give a quick update on where the project status is. As many of you who are involved in the project already know, Traces has been stable on the project for a while now. It's been stable since last year. Metrics is also stable at this point, and there's some work that is in progress right now with some of the language APIs, but most of the more predominant language APIs and SDKs are all stable at this point, with full metrics support as well as interoperability support for other common protocols like Prometheus and other standard ad hoc standards that are being used today, which are really legacy protocols, but slowly but surely being fully interoperable with OTLP. Also wanted to call out that logs is in development right now, and there's a lot of progress being made. So you'll see basically the whole set of SDKs as well as the collector flip to green as by the right now we are targeting the middle of 2023. So kind of leading towards that, and signals, other signals such as profiles and events are also coming into play. There's a fair bit of requirements and semantic conventions that are being discussed for both of these signals as they get added to the project. And please, again, there are work groups for those and SIG meetings. So if you're interested in those areas, please join in. And there's a lot happening. So what I wanted to call out here is that there's some trending areas that are being discussed right now and are actually being worked on the project itself. And specifically on OpenTelemetry, there is the end user work group, which actually is a very good forum for providing feedback back to the project and the maintainers on what are some of the requirements of feature sets, as well as implementations that could be optimized and improved, including performance and configuration concerns you might be seeing, or improvements that you might to see. There is the web maintainer team has continued to expand, and why that matters is that the project also is very committed, just like the Kubernetes project, to provide good documentation. And documentation is super important, both for developers as well as end users and operators in adopting OpenTelemetry, as well as being able to use all the different components well and instrument them. Improving the contributor experience. That specifically means, again, increasing the footprint in supporting better client instrumentation, as well as looking at a control plane for OpenTelemetry. And again, these are all discussions as well as implementations that are in flight right now. So please, join in if it's an area you're interested in. Profiles, as I talked about. So implementation of profiles as well as logs, and real user monitoring using events is something, again, which are all in flight, and exciting times, because there's a lot of design as well as implementation discussions that are ongoing, and actual work, actual code which is being developed there. There is a demo application, which I will share with you a little right after, which again would be good to try out. Again, this is the objective of the project, is to have a demo application that you can use this and go try it out. It's a playground for you to try. File-based configuration, capturing telemetry from CI/CD systems and integrating with CI/CD systems like Jenkins, and other Argo, etc., is something that's being discussed. And also semantic conventions, establishing conventions for cloud spend as well as security is another area. Adding additional support for Kubernetes metadata, as well as a very interesting discussion and proposal on developing a standardized query format for observability and for telemetry data. So just wanted to kind of call these out, because these are some of the areas that again build towards the larger goal of having in-depth observability that is out of the box, easy to use, and standardized. So OpenTelemetry has a demo, as I said, and this is, again, please feel free to use this. This demo is actually pretty well built, and actually can showcase how you actually integrate an instrument with 10 of the 11 OTel language SDKs. You can also implement traces and use an example accordingly, creating custom spans for richer and more useful traces using auto instrumentation. How do you instrument using auto instrumentation? Propagation of context, trace context, as well as both manual instrumentation as well as automated. Passing data attributes, again, some of the complexity in instrumentation as well as setup, right? So this is a good way to kind of deep dive into it. And please check it out. This is the URL, as well as there's extensive documentation on the site to go and deep dive in. That said, again, my request to everyone is please get involved, because there are several discussions happening both on the specification side, as well as the protocol and the implementations, which really lead to the thinking where how do we actually standardize, commoditize, and continue to build a standard implementation that actually can be used for all types of telemetry data and better understanding your systems. So that said, this also leads to other areas. How do we do better analysis? How do we actually pre-process data to do better analysis? Would it make sense to go and apply ML techniques and other techniques to be able to analyze data at scale, as well as visualize, right? Which are other parts of the system, and we can. There is a lot of detail there also, but I kind of wanted to focus in on OpenTelemetry today. Documentation, OpenTelemetry.io, as well as GitHub is GitHub/open-telemetry. So with that said, thank you again, and happy to address any questions that you may have.
All right, thanks, Alolita, for this presentation. I already have a couple of questions also, but let's ask them once we are at the panel discussion. There are a
Thanks
couple of
again.
topics that you mentioned about events and so on, and I was not aware of that, so I'm probably going to ask more questions about the events itself. So let's wait to chat about it during the panel discussion.
Thank you.
So now that we have two speakers that presented their talk, we have our last speaker, which is going to cover a bit similar topic, but more on in open observability, the standards. So I'm referring to Michael Hausenblas. So I leave the stage to you, Michael.
Well, hello, and thanks for having me. Pleasure. We heard already quite a lot about open source observability, and that's awesome. And I'd like to focus on a topic that is maybe not as often talked about, but in my understanding, very, very fundamental, and that is open standards. Now, first off, I'd like to address the question, why open standards, right? Like, what's the opposite of an open standard? And maybe even step back a little bit and clarify the terminology here. So if you see somewhere the word specification, that's typically something where an individual or an institution writes up a certain system behavior, might be a data format, might be a protocol, but that doesn't necessarily imply it is a standard. So how do you turn a specification to a standard? Well, that's usually through consensus, which means in a sense, you have some mechanism that turns this specification, so a document that describes the behavior, into something that various stakeholders agree upon. And that leads us to interoperability. Meaning, if you have different vendors that agree on a specification and implement that, it means these different systems, think of an agent, backend, for example, are interoperable. You can plug them together. You can swap out the implementation. And last but not least, from an end user perspective, it obviously helps to mitigate lock-in, right? So if you have an API, an offering that is based on an open standard, and by that I essentially mean that everyone has access to the specification, can download it for free, implement it for free. Then you are to a certain extent safe against this kind of lock-in. Backing it up with a little bit of data here, the OTel adoption survey that I ran earlier this year, it's available on GitHub if you want to have a more closer look. That was actually the number one reason why people think that adopting an OpenTelemetry is an important thing for them. So let's have a look at the basics, right? The access to the specification that might sound in 2022, obvious that everything is available online, but there are areas and there are standardization bodies where you actually have to pay to access the specification. I won't name names, but believe me, I've been in W3C in the Northeast quite active, and looking from a standardization body like that, where it's clear that you're producing open specifications, open standards. It's not always that. Talking about bodies, right? There are a number of usually not formal standardization bodies, but organizations that allow various vendors, competitors effectively, to come together and write these specifications with more or less formal process. Which also leads me to greenfield versus after the fact. Ideally, and that is a little bit the thinking in IETF, you standardize after the fact. So you have a number of different implementations and trying to standardize the way how things are supposed to be, versus greenfield, where you essentially first write the specification and then ask vendors to implement things, which can be quite tricky. Again, speaking out of own experience in W3C. And then there are dependencies, and that is various specifications depend on each other. And you can kind of think of that like a stack, and that can be tricky, right? So if you have, for example, a specification that is updated and your specification still refers to an older version, you need to have processes in place to make sure that you're keeping up to date. Last but not least, adoption. Just because something is a standard, that could be a de facto standard, industry standard, every major player in a space agrees upon that, or a more formal type of standard, at the end of the day, what counts is adoption, right? And there's a real risk. We've seen that, for example, think of IPv6. That was for the longest time a de facto standard, right? An IETF document that would specify how to handle IP addresses in a scalable manner. However, it took quite some time until it was adopted due to various reasons. The reasons don't matter. At the end of the day, what counts is the actual adoption. So the more adoption, the more broad adoption a specification has, the stronger it is as a standard. That's something to keep an eye on. All right, so on a high level, obviously we are all using so-called web standards. That could be HTTP, URLs, etc. Then there are also a number of, they're not necessarily formal standards or formal specifications. Many of them came out of various projects, or sometimes even individuals, if you think about JSON, that established a de facto standard, how to, for example, represent data on the wire. And now I'd like to talk a little bit more about some examples of observability specific specification and standards. I'm not claiming I'm covering all of them, but I think they're the most important for sure. The first example comes out of W3C, that's the trace context. And this is something that's in isolation, maybe not as important. W3C publishes a number of those. They're called recommendations. And also an example of a standard that represents a dependency, because come to that later on. Another standard refers to that and declares that as a dependency, saying the way how we do context propagation, so embedding the trace ID into a header and propagating that across different services is according to this trace specification, trace context specification of W3C. Another example that kind of organically came out of a project, out of the Prometheus project, was looking at the way how metrics are represented on the wire through the Prometheus exposition format, textual format, and essentially taking that to IETF and standardizing it, which is now open metrics. And again, you see how through a community and through adoption, something can become a standard. last but not least, we have heard about OpenTelemetry already quite a lot from Alolita, so thank you for that. I just wanted to point out that, in its core, one very important part of OpenTelemetry is this specification. This is something that covers the actual way how to represent logs, traces, and metrics. It is how you transfer them on the wire through gRPC, through protocol buffers, HTTPS, JSON, whatever you're using there. And it also defines, where to look for it, where to ingest metrics, traces, and logs. And again, the power here is that if you effectively ask for, you go to your vendor, you go to your provider and ask, are you interoperable? Are you implementing that? And Dieter also already hinted at that earlier on. Then through the combined effort, you can help making these systems interoperable. So summing up here at this point in time, and I intentionally kept this very short because I'm looking forward to a lively discussion afterwards. If you think about open source observability, my ask would be always add, at least in your mind, and maybe even aloud, open standards to it. The importance of open standards, interoperability, and you make a real difference by adopting open standards. And that's it from my side.
All right, awesome. Thanks, Michael. I had a couple of questions, in fact, and I think I'm pretty also eager to start the panel discussions. So we'll try. I think we will probably have a 10 to 15 minutes discussion about that. So let me just launch the intro and see you for the panel discussion. All right. So now we covered the different topics coming from the SRE perspective, and then a lot of great updates related to the OpenTelemetry project, and also all the reminding about observability in general with the Alolita's presentations. And then also thanks to Michael reminding a couple of open standards. And you mentioned a really interesting aspect is that adoption is key for all those projects. So I think it's I fully agree with you. And I have lots of questions on in general topics, and starting on the presentation that Steve made about SLO. And you mentioned about one SLO for data processing. So, and as you know, Alolita shared about the collector, and the collector is one of the components that will process telemetry data. And because we're using it to be able to extend the observability of our environments, it seems to be a critical component that requires an SLO behind to at least make sure that all those collectors that we probably have deployed in our environments are healthy and running and doing what is expected. So you mentioned some examples about with the frames for video games and other things. So how could we, at the end, if you think about the problem where we have incoming signals to the collectors and we have outgoing data processed. So how could our community build SLO that will make sure that this component is doing what is expected?
Yeah, great question. So, I mean, the collector and the rest of the OpenTelemetry pipeline is a pipeline. In fact, it tends to be like a series of pipelines, right? It's like a set of parallel pipelines, maybe coming from each cluster that you have, or each sort of like production, piece of footprint to some central, or probably even a few different centralized locations for redundancy. Because of that, you want to make sure that like that pipeline as a whole is working well. So often inside of Google, at least, we call this meta monitoring. So it's like the monitoring itself is used for determining if the system is working well. We also want to make sure that the monitoring system itself is working well. So it's like, we call this like who watches the watchers, right? So meta monitoring is a really important signal. And like when it, breaks, you need to have like an out of bound way to like determine it and all this stuff. But one of the really important signals though is exactly this, which is like, are the bits coming from, like the compute layer or the storage layer or the network layer? Are they making it through the pipeline to the other end? And you can do this exactly through something like freshness. So one of them would be if I have a summation of rates or something like that I want to collect from many locations and measure it on the inside. When they're collected by the collector, they can be annotated with like the date time of collection, and then once they make it out the other side, you can measure like when they kind of appeared, when they were made available. And either that can be done, I don't know, in the collector or through some other method, and you can see what the delta is. And so for one, just think of like one metric point coming through the system. You can imagine there's like a number there that says how fresh that number is as soon as it comes out the other side. What you want to do is be able to then take that number times all of the numbers that are coming out all the time from all the different places and sum them all together and come up with like how fresh is our entire set of signals coming through these collectors, and determine like, well, we want to make sure that we have within, I don't know, 5 seconds or 10 seconds or whatever the number is. That's just going to be our goal. That's our SLO. And so we want to say like how many of them are succeeding, and maybe we'll find 10% of them are not making it within that 5 or 10 second goal. Then the next step is to step into that and say like, okay, which 5 or 10%? Is it ones that are like going across an ocean? Like, is it a long wire problem, or is it like the content of the metric itself is doing like a lot of rounds through the collector and through like all of the summation, and it's just doing a lot of math? Maybe that's part of the problem, or maybe the collectors are just under resourced, right? Maybe they're just queued up, right? And so there's a lot of reasons for why this SLO might be in violation, but you won't really know to even start looking until you see that there's a clear signal of like the system isn't working as well as we intend it to, and that's where this SLO would come in well.
And I guess Michael and Alolita, you probably also use collectors within your work in general. So have you thought already to implement that type of SLO to keep track on the health of the collectors?
I can go first. So as Steve mentioned, it's there are again different layers that you're looking at, from a performance perspective, right? And depending on how the collectors are set up, first of all, there are specific considerations when you define SLOs that you need to take into mind, into effect, where you are saying that, hey, this if it is a network layer dependency, then in the configurations that you have, then what do you need to factor in there as performance? Is it latency that you're measuring? Is it volume? Is it again response time? There are many ways to actually set up or define an SLO, right? And so when you are having a complex environment where you're running hundreds of thousands of collectors, and that could be running in one region or multiple regions, globally, all those considerations are taken into account to define an SLO, first of all, and secondly, to kind of define, what is a normal response time based on that versus what's abnormal, right? So yes, when you have complex configurations and you have a complex network that you're working with globally to provide a service, you are defining SLOs not only at the infrastructure level, but you're also defining SLOs at the application level.
Michael, do you also have because I think there's a distro that is providing on the market from Amazon. Is there also Amazon has already provided some process or some way of getting that feedback from the health perspective
Yeah,
and the processing perspective?
right. So yeah, so first thing I want to point out is that the collector itself is really, I would say, from a visibility perspective, really already pretty well equipped, right? So you get not just logs out of it, you get metrics, although there is some effort underway to enhance these metrics, or in addition to what currently is there in Prometheus format, also offer OTLP. You get profiles out of it. Not sure about traces. I believe currently not, but Alolita, correct me if I'm wrong there. So there's everything in place, and we have dashboards, Grafana dashboards, for example, for the collector to make sure that we understand the pipelines, that we understand overall resource usage, etc. I think there can be done even more. I will eventually also contribute to upstream docs that handles or talks to these operational issues. And having an SLO-based approach in that, I think, makes absolute sense. I would say it's not yet everything in place or in a shape that comes out of the box, but the building blocks are there, and certainly we see customers asking for exactly guidance around that. So yeah.
Yeah, and just to add to Michael's point, the collector today is already has a baseline of metrics that are actually used, especially through the host metrics module and other specific modules in collector core that emit the system performance, the collector performance, with specific metrics, right? And you can actually take that as a baseline for every instance, and then be able to actually compute your service level SLO, service based SLO or application based SLO accordingly. But it's again, just to emphasize, it's configuration driven. It's also driven across the different collector configurations that you have.
And I have a question because related to the project. So you mentioned that. So I'm going to just drop a link that to make a reference. Yep, here it is. So if you want to relate to what has been shared so far, here is the link if you want to take advantage of that. So for those who's not aware, in the SRE and SLO space, there is a project called OpenSLO to standardize the definition of your SLI and the definition of the SLO. And I was wondering if in that direction, from what you mentioned, Alita and Michael, if the open SLO standard will be in the future utilized by the OpenTelemetry project. So then at the end, the collector will have a preset of SLO defined. So then users who are not experts could maybe take advantage of standards that the community has built on top of the collector.
Would make sense in my understanding. I'm not aware of anything active there, but would absolutely
I think
make sense.
Michael, actually, OpenSLO has been discussed on the project, but I think Henrik, to your point, in the long run, yes, that is something that is very required, and perhaps some more in-depth work needs to be done on that in terms of how that would be applied to the different components in an collection pipeline, especially you leveraging the open source, the collector itself, as well as the APIs, because again, each segment it plays a part in the larger SLO that you're defining, right? And it also is having a baseline definition for what does an SLO actually mean at a component level versus on a pipeline, for a service, right? And I think that work yet needs to be done, but it would be valuable to leverage the work that has been done by the OpenSLO project and apply it there. I mean, Liz Fong Jones, as you know, and others have done some significant work on, definition of SLOs for services that leverage the collector. But I think that that there is more work to be done on the project itself.
Very, very interesting, and I'm very eager to see that, to be honest. And I had a questions to you, Alolita. So you mentioned a couple of things that I was not aware. So I know that continuous profiling, the specifications is underway, and you mentioned events, and this is something I never heard about it, and I'm very excited. So I was always asking myself, also maybe the events will be trapped through when you instrument your application through using open telemetry and creating spans, and then you have an exception, you trap it, and you send your spans in error and you add the exceptions. But what is there an actual working group or anything related to specific to events and exceptions to
Yes.
add that as well in OpenTelemetry?
Yeah, and there is the client instrumentation SIG, which actually has been looking at the at use cases for real user monitoring, and specifically events that are generated, and working towards defining semantic conventions, around events and specific types of events. There's some work that has already happened, but there's more work that needs to be done. But again, events is integral when you have again, uh, clients client systems as well as applications intersecting with the larger infrastructure and services stack, right? And events are critical in being able to understand the behavior and monitoring end to end, for just from an observability perspective. So the client instrumentation SIG is actually working on that, and there have been several enhancements, open telemetry enhancement proposals that have been made, and you can check them out on the project and the community repo, where and the OTAP repo, where you can look at some of the proposals that have been made to handle real user monitoring events. And now, just to be clear, there is a difference between the implementation of what OpenTelemetry is supporting today versus what could change in the long run. Where the first current assumption is that we could use logs under the hood to be able to represent events, but in the long run, it could be that if there are enough use cases, profiling included, then there are distinct telemetry types that actually exist to handle events also, right? So profiling definitely is a fourth telemetry type, but events is still kind of being implemented with the logs approach, but may change because it has its own unique set of attributes and characteristics that in specific use cases, especially when you're doing client instrumentation and client monitoring, are very different from what you would typically see on service infrastructure.
And there is a standard that has been built and basically part of CNCF called Cloud Events. And at the moment, there is as like a child project out of Cloud Events called CD Events for continuous delivery. So having a specific specifications for continuous delivery events. Is the project thinking of creating a specific set of events respecting the Cloud Events format that would be specific for telemetry, where each component could be pushing events, and then maybe the collector will be listening for events, and then we'll be able to parse it and so on? Is this something that is the sort of the final solution design, or is it something else that you
No, I
speak
think
with
it's in
discussion?
discussion right now because, as you may have heard at KubeCon, recently in Detroit, there was a fair bit of discussion around, intersecting also with the build pipelines where there are observable events which determine what the application behavior is going to be in, at the end of the day, right? So that said, there was a fair bit of discussion around how we can leverage the work that has been done by the sub projects that you mentioned, where that could be actually integrated as a set of events and the semantic conventions associated with that to be consumable by the collector.
And other almost related question is that there is this notion of exemplars that was introduced by metrics, where you can link metrics and traces together. Is exemplar going to be extended for all the signals, where you could attach events for a specific trace ID, for a specific context? So then when you get it back to your observability solution, then everything is linked together and glued together. Is it something that also is going to be extended, the notion of exemplars, to other signals than just metric and traces?
Yes, I think that was also an open item that was actually itemized for discussion, design evaluation, and then implementation in the long run. But there's work to be done there, right? I mean, obviously, typically exemplars are used in very specific use cases, as you said, between traces and metrics, or traces and logs. So again, extending that to other signals and how that would be handled should be something that the specification needs to address.
Okay. Michael, you mentioned adoptions. So what would be, because here we are relying on OpenTelemetry quite a lot, and also there's other standard like Open Metrics. There is also other standards. I mean, not standards, but we are using it by de facto. Sometimes it's Prometheus. So how can we make sure to increase the adoptions of those standards? So then we are sure that everyone is using it, and then everyone is successful, because we have a standard format of producing stuff, and we don't need to again be vendor locked in again.
Right. I think there are two parts to it. The one part is essentially for people new to a specification, and that is having really great getting started material. That could be anything like a recipe. Here, go do these things. That could be, if you think about the OpenTelemetry demo that Alolita mentioned as a kind of reference. This is, how you can get started, and you can, take that as a starting point and then change things there. And then there are, for more advanced users, effectively best practices, or if we are honest, we should say good practices, because all what we are doing here is not old enough to really have best practices, but essentially a set of here's what we learned from running this in production for quite some time. Do this, don't do this, which effectively is written by practitioners for practitioners. So if you're already into it, you ask yourself, okay, I'd like to productionize. What are the things, what are the gotchas, right? What are the things I should be aware of? What should I be doing in terms of scaling, in terms of securing it, etc.? That might not be obvious, right? Because the specification just says, do this or that, you have to implement this, you may implement that, but various implementations may differ, right? There is something should be this way or maybe this way. An implementation may choose not to do that. And for that, you typically have these compliance and interoperability frameworks. Prometheus already did that. I'm not sure where we are with OpenTelemetry, but we should definitely have a discussion there. Essentially, making sure that if someone says, yes, vendor X, I'm offering an, let's say, OTLP endpoint, how can you, as someone who is programming against that, using that, taking that as a dependency, make sure that this is 100% compatible, or to whatever percent you feel free. So summing up, for beginners getting started, great examples, reference material. For more advanced users, having these collection of good practices that essentially guide you, and not making the same mistake twice. It's always good to make new mistakes, right? Why repeat the old ones?
Yeah, I fully agree. I mean, the OpenTelemetry demo is a great start. And I think if we provide more and more content to help people getting started, and also simplify a few things in the way of implementing it, I think it will be increase significantly the adoptions here. I think I don't have any more questions on my end. Do you have any questions to ask from the other presentations, to Steve or to Alolita's presentation, or to Michael? If not, no questions.
I think all I request is that everybody join into the OTel discussions and make observability even better.
I agree. I agree.
SLOs by using open standards. We've wrapped up.
Yes,
everything.
absolutely.
Agree.
That's a baseline for all work, open source work.
All right. So first of all, I will thank you, the three of you. I mean, Steve, thanks for being here, taking the time to building the presentations. Thank you, Alolita, as well, for taking the time to build the slides and present them to our community. And Michael as well. Thanks so much for taking all the time and investment to do this. So that was the first edition. So I will thank all the speakers and make a small conclusion. So thanks for being here, and I hope that we will see you in the next Observable Talks.
Totally. Thank you so much.
Welcome.
Thank you. Bye-bye.
So I'm going to just conclude this first edition of the Observable Lightning Talks. So we had 3 different speaking track, relevant, very interesting on covering different topics. SRE with Steve, of course, Alolita on the open source and observability with the product update of OpenTelemetry, and last we had Michael with the observability fundamentals. So if you enjoyed today's content, don't forget to like and subscribe. And the idea is I want to improve this format. So drop your comments if you had any suggestions on how to improve that format. But at least I would like to thank you, everyone who has been connected live for this first Observable Lightning Talks. And for those who was not able to connect it live, don't worry, it's available on YouTube, so you can still watch it and enjoy the content. Thank you so much for your time and your energy. See you soon for another Observable Lightning Talks.